Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard with the Future Tech podcast. My guest is Philip Holl. He's from the Technical University of Munich, and we're going to be talking about the projects he's working on in holography and machine learning. So, Philip, thank you for coming.
Well, thank you.
Yeah. So tell me about your work in holography and machine learning. What are you working on at the university?
Right. So the holography project is pretty much over right now. So this is what I primarily did for my bachelor thesis. And the basic idea was to record all the Wi-Fi signals and basically, create a hologram out of this.
A hologram of what the Wi-Fi signals look like in space, or the data contained with them, or what do you mean?
So you probably know the regular holograms you record with usual light, visible light, and it's kind of similar to that. But instead of printing them on a sheet of paper or something, we record them in the computer. And so we have this kind of three-dimensional information in the computer afterwards and can generate images on software.
What kind of images are you what information are you trying to gather, and what are you trying to create from the hologram?
Right. So the way it works, it's pretty similar to a regular hologram in that we record all the Wi-Fi signals that pass through a certain plane. We decide the bounds basically, and on one plane we record all the Wi-Fi signals that pass through. And this plane basically is then the hologram afterwards. So by recording all the signals, all the electromagnetic field basically, we get a pretty good idea of where these signals came from.
So you're trying to identify where certain Wi-Fi signals are coming from?
Exactly. And
what would be the use for this?
So there are multiple use cases for this. For example, you could use it for tracking. So let's say you have an indoor system and you want to track people or track devices attached to their bodies, for example. That would be a use case. Or you could also use it to find things. For example, say after a snowslide, you want to find people that are buried under the snow. You could use the radiation sent from their mobile phones to pinpoint their location, basically.
Okay. So you can pinpoint people's location that are transmitting signals. I guess this would be for what, counter surveillance or surveillance purposes?
Well, maybe, but there are actually easier techniques for this. So that's also the main drawback of the holography technique, that you have to record on a large plane, basically, so many meters across, and that usually takes a lot of time. But if you do that, you get actually more than just the position of the source, but you can also get the outlines of objects in between the source and where you record it from. And you get kind of this three-dimensional picture of everything that was in between. And so this is kind of what the hologram is.
So you're using background Wi-Fi that's present to identify objects in a room, or what would be the reason or the benefit of being able to see objects that the Wi-Fi passed through?
Yeah, basically that is the key concept. It's very similar to like just looking at things, but with Wi-Fi, and that has some differences. So as you may know, Wi-Fi radiation is also electromagnetic radiation, just like visible light, but with a much, much longer wavelength. And so that means that it can pass through objects like walls. So just like Wi-Fi, when you get a reception outside, the Wi-Fi passes through the wall. And and basically what the hologram is a picture of the world as recorded in Wi-Fi, basically. So if we could see Wi-Fi, this is what we could see.
So what are some of the use cases that you thought of being able to do this? Being able to see into a room without going into the room? I mean, maybe for police? I don't know, what would be useful?
So actually there was, I think the US military actually thought about this. And I don't know what the status on this is, but I doubt that this will be used by police or military because they're just easier techniques to find or to locate sources of radiation behind walls. Really, the new thing of our technique is that you can also see the object. And yeah, I mean it's mostly at least the way we did it. It was mostly for academic purposes to show that it is indeed possible to record these holograms. And we are actually not implementing any applications ourselves. So this is all hypothetical.
Oh, but what interested you in it? Just being able to do that? Or is there a use that you thought of that you think would be really cool for this?
Yes, so just locating things I think is really cool. And if you go a bit further in development, it might actually also allow you to make some things easier that require identification, like RFID tags, for example.
Yeah.
So, for example, imagine you're in the supermarket and you buy some things. Now you could stick a small RFID tag to every item you can buy, and then at the counter you could just put your bag onto a spot there, and it would automatically scan all the products without you even having to open your bag, for example.
Right.
And that could be done with such a technique, which combines the localization with the radio frequencies there.
Yeah, so like I think Amazon was working on something like this, where you could just walk out and the sensors would see what you have in your bag and just charge your account. So you don't need almost anyone in the store to help you.
Right. The way they do it, I think, is they use cameras, actually quite a lot of cameras, and they track where the object has gone. And if it's in a bag, they just remember that it's in the bag. But you need a lot of cameras to do that.
Yeah.
And if you could just scan inside the bag, I mean, that has advantages. And you could also use this for industrial warehouses to stick just RFID tags onto all the wares.
Okay. So you said you worked on this, and then you've changed what you're working on. So what are you doing now?
So right now I'm doing more machine learning / artificial intelligence related work. But I think the Wi-Fi holography is by far the most interesting project I've worked on. So since then, I've done some work for a big physics experiment, which is called GEDA or JEDA. And this was for basically classifying very rare events in being a real event or some background nuisance.
Oh, what kind of rare events?
So the way it works is there's this hypothesis that neutrinos and antineutrinos are the same particle. Neutrinos are an elementary type of particle which we know very little about, and to observe whether it is its own antiparticle, one can look for a certain decay in germanium, and this is basically what the experiment does. But even if the neutrino is its own antiparticle, this decay would be incredibly rare and would, even with the amounts of germanium they have, only occur less than once a year, basically. And so you have to isolate all other known sources of radiation, and I worked on some software, especially artificial intelligence, that was in charge of, or might be in charge of someday, deciding whether an event could be a real event or some background event from other sources.
So for particle decay, they want to detect whether a particle that's released is it's a real particle or it's just a random occurrence, a random fluctuation.
Yeah, basically the question is where the particle came from. So if it was really such a decay, then the particle would have been created within the germanium, and it would be within a very small region of the germanium crystal. But if it was some externally induced event, for example, radioactive decay from the walls or so, then it is most likely to have left a trace inside the detector. And this is what my algorithm looks for.
Okay. So yeah, what other projects are you working on?
So right now, I'm working on a completely different topic again, but also artificial intelligence related. And right now it's more fluid dynamics and artificial intelligence. So it's basically using artificial intelligence to solve fluid optimization problems. And that means basically doing, for example, let's say you have a robot and a robot wants to pick up a glass full of water. Now obviously the robot doesn't want to spill any of that water. So it needs to understand how the water behaves inside the glass and to pick it up correctly. And this is a typical application for artificial intelligence. And yeah, basically I'm working on these kinds of problems where you have some agent or some intelligent system that needs to understand how fluids work or smoke works to basically interact with it.
Okay. What do you mean interact with it? Like what would you do as an interaction?
So in the case I just mentioned, this could be a robot one day that does it. But in other cases, you might want to exert forces upon a simulation to achieve a specific result. For example, say you have a smoke simulation as a visual effect for some movie, and then the artist would like to have some more control over the simulation. And basically what the artist would like to do is specify where the smoke should go, or like some end state of the simulation. But what artists have to do these days is just fiddle with the initial conditions until it turns out right. And with some artificial intelligence, they can take care of all that and apply wind forces wherever necessary to guide the smoke, basically.
Right. Okay. I gotcha. Huh. Interesting. And then in the handling of fluids, like you said, a robot hand would be better able to handle a fluid. I've heard, for instance, in surgeries, like the Da Vinci robot, one of the problems it has is the resistance of the skin and the tissue changes, and it's very hard to figure out how to let's say make an incision. And if the body moves or the skin moves, or this might help with surgeries like that, for instance.
Yeah, so that's soft bodies, but that is actually very closely related to fluids. So that could also be an application in the future, possibly. Yeah.
Yeah, it's just something I thought of as you're describing it.
Yeah.
Very interesting. Okay.
Point.
So where do you want to take your focus? You worked on a whole bunch of projects, different applications. Is there something that really fascinates you that you want to focus on from here out?
Right. So currently I'm in my Ph.D. Doing this fluid dynamic plus artificial intelligence. And actually, I probably also would have liked to continue on with the Wi-Fi holography project, but for various reasons, including financing and also internal reasons, that didn't work out. But yeah, so now I'm going to continue with the fluid dynamics for probably 2 to 3 more years, and then we'll see. I don't really have a long-term plan right now, but it's probably going to involve some more artificial intelligence.
Yeah, you said the thing that seemed the most interest you was again finding the shapes of things using holography, of Wi-Fi signals. It sounds like you have more use cases in mind. Since that fascinated you, is there anywhere you want to take that?
I think the most applicable use case is probably the industrial case where you want to tag objects and see how they move around or label them. And I know a startup, for example, that is working exactly on that basically, and tracking objects within a warehouse using RFID tags. And maybe I'll end up somewhere there. This could also have applications for deep learning when you try to track objects in more complicated environments, because you get all those rays that get reflected off other objects and then also reach your receivers. And so in the end, the picture you receive is basically an overlay of all the objects that scatter the radiation, and it's non-trivial to separate all of the information into the different objects and what ray came from. So there might also be some machine learning involved on that front to basically identify all the objects that you saw.
Yeah, one more question about the identifying objects. Once Wi-Fi passes through one object, I would see, okay, you can identify it. But what if it passes through a second object? Wouldn't that distort the Wi-Fi in such a way that you couldn't recover the first thing it passed through?
Right. So that's actually where you need the whole plane, because if you record all the signals on a larger plane, then you kind of can look at everything between your source and your recording plane from all the angles that have their viewpoint on the plane. So you can basically look at the source from the left and from the right, and the idea is then hopefully that the walls did not cover all of the space, and then you can see that one wall only reaches, I don't know, to some meters to the right, and after that only the other wall is left, for example. And that would help you to identify the different objects. But if you really had two walls that went all the way through, then it's more or less impossible to correctly identify and where they are and how.
Plus, you couldn't deconvolute if it went through multiple walls or multiple objects. Yeah,
I mean, there might be secondary effects which could allow you to do it in the end, but definitely not easy in such a scenario.
Okay. You mentioned other techniques that are easier for identifying objects in rooms. I'm just curious what those are. What have you seen?
Oh, there's passive radar, for example, is a common one, which is also used by the military. And there's others, but and the advantage of these is that they only require one antenna or a few antennae, possibly one array, but then they can record it instantly. But the way we do it is we have two antennas, and one of them has to move around to cover all the plane. And this takes a long time in our setup. So for our scans, the way we did it, it took a couple of hours for the big scans, because the antenna has to move up and down and then slightly to the right, the way we did it, and has to cover all of that area. You could make that faster with arrays of antennas, but it's still rather slow to record all of the objects in between. If you're just looking to locate an object, then a couple of antennas should be enough to get real-time data acquisition rates.
Okay. Well, very good. So if people have questions or ideas for collaboration, or they have input on some of your old projects or current ones, what's the best way for them to get in touch?
If it's about the Wi-Fi project, they can mail me. My email is on the paper.
Okay.
And for the other stuff, so the physics experiment, we're gonna publish a paper soon. And else, just email, and should be able to find this.
Okay. All right. Well, very good. Well, Philip, I appreciate you coming on the line, and it's pretty interesting stuff you're working on. So, thank you.
Yeah, thank you for the invitation.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.